All right, this talk is about how Adobe integrated Salt into our CMDB. Kind of our journey to get there, why we did it, what we tried, what didn't work, what did work, what we're using now, and what benefits we get out of that. So yeah, now I will, right up front I'll say, in my previous talk, I got to announce that we open sourced something and everybody was very excited about that. It's not the case in this one, so sorry. The problem, I mean, I could give you our CMDB module code and stuff, but our CMDB is proprietary. It's an in-house thing we built, so you couldn't really use it anywhere. But the concepts, hopefully you can take the concepts, the same ideas, and if you want to do the same thing, this will hopefully steer you down. You won't have to learn from the same mistakes that we did, is mostly what I want you to take from this one. So first of all, does everybody know what a CMDB is? Does anybody know what a CMDB is?
Is it some sort of database?
It is some sort of database. Yes, thanks Larry. A config management database. It's essentially kind of a data warehouse for all of your inventory, your configuration of your systems, what their roles are, where they are. We use ours for, what data center is in, what rack is it, what's the serial number, what's, what vendor is this from, what's the warranty like, and then device information, things like CPU, RAM, and disk, and kernel version, and all that kind of stuff. You want to be able to look up quickly and go find, maybe who owns this machine, or what are the attributes of this box, or whatever. So who does not use a CMDB now? Okay. Do you find that you're fine with that? Are you looking for a solution? Maybe that's why you're hoping I could just hand it to you on a platter. In my history, I've seen CMDBs as rudimentary as like a spreadsheet. Maybe some of you have done that too. There are some solutions you can buy. There are some available ones. Again, ours is we have application development team in-house. They build and they maintain our CMDB. So we have a lot of custom stuff that we needed. Now we have Salt and we have a CMDB, but why combine the two? What's the benefit there? The way I see it, there are certain things that a system knows about itself better than anyone else. And there are things that a CMDB knows about it better than, let's say, the host. For example, everybody's probably familiar with Salt's grains. It keeps track of most of the attributes of your system that don't often change. CPU, RAM, kernel, distribution, memory, a bunch of stuff. So the minion in the grain system knows a lot about itself, and those grains are populated when the minion starts, so they're generally pretty up to date, and they're refreshed. If you have to reboot for a new kernel change or something, the minion's going to restart, it's going to see that change, it's going to update its local system. But there are other things that generally are stored in the CMDB that a minion wouldn't really know about, like what rack am I in, what colo am I in, what data center, what site, what city, what, So one thing that we found is you kind of have to pick what you need here and pick what you need here and then combine them. And then you get the best result. You can't have one of them be the full source of record because they each know things about the other that the other doesn't know. But, and this is the biggest problem I think I found with my experience using the CMDBs, is that the A CMDB is only as useful as its data is accurate. So of everybody that is using a CMDB, how many of them are probably a little out of date, right? Well, I think a lot of us, unless you go in and remember to update it or something, and then, well, I know the records have got to be 3 months old, so I just don't use a CMDB anymore, right? I've heard that from other people too. Yeah, we have one, but we don't really use it because we know it's all out of date, and we don't have really an automated way to keep it up to date. So I'll talk about how we blended the two worlds, the CMDB's world and the Salt world, and how we keep the CMDB up to date automatically. So we set out, okay, we want to tie Salt into our CMDB. Challenge accepted, let's do this. So the first, when I first started looking into this, I thought, okay, there's probably two ways we could build this. We could do it with the grain system, because the minion already keeps track of a bunch of grains. Maybe we just pull the data from CMDB and set that in grains, and then we just extend our grain system with more data. Or we could do it in pillar, because those are both of those are kind of just data stores in Salt, slightly different roles, but you can put the data in either place. And so we thought about where should we put this? So in our first attempt, we thought, let's go with grains. Grains are attributes about a system. The CMDB stores attributes about a system. So let's pull those together. Now, the way that our CMDB is set up is we have a nice web UI for it, so we can manually go in and look at things and do searches and whatever, but it also has a nice API. So we wrote a Salt execution module that can query the CMDB API, query for data out of that, and then inject it into the grain system and extend the grains. Now, my first thinking with that was, if we do it on a per minion basis, we can have different minions in different roles query for different types of data. I want the databases to have more certain attributes from the CMDB than the web servers have, or something like that. We could configure it per minion, because each minion is going to reach out and ask by itself or for itself, what is my CMDB data? So we built that, and we started using it, and then we found we ran into some problems. So we're working on this. We write the execution modules to do the queries and populate the CMDB data. And then, I don't know how many minions you guys have, but we have a lot. We've got in the tens of thousands. And just for a second, if you have a thought experiment with me, tens of thousands of hosts, all sending requests to a single endpoint, and we DDoSed our CMDB and took it down. Oops. So we kind of realized maybe the grains method is not the best, because each minion is going to ask on its own. So we've got new connections, new database queries for every single minion, and they're all going to refresh on some cycle, and that's going to be a lot of hits to the CMDB, and so it's probably not scalable. So we got to reevaluate this. So we did like so many programmers do when you code something up and then you realize, this is not going to work, and you throw it away, and you have to start over. But some of the things that we learned, and I want to share with you guys, is some of the things we learned along the way and why the grains wasn't the best solution for us. So challenge failed, sad face. We have to try again. So what didn't work? When we did it with the grains method, each minion would communicate with the CMDB API on its own. That also means that every minion would have to have access to or copies of the CMDB API credentials. So those would have to be distributed to and maintained on every single host, which we kind of don't like, because then every single host has the credentials to the API. Somebody might get into random host over here, but oh, now I've got credentials to the API. Let me go delete entries or something malicious. Maybe I don't want the credentials everywhere. Per minion connections to the CMDB was additional network traffic and additional load. And like I said, at one point early in our testing, we DDoSed the CMDB. So that's something we wanted to be able to improve on. Also, if you're familiar with the grain system, the grains don't really update. They're not meant to change that often. They're generated when the minion starts, and then they're just set. So if we need to change grains or add grains, we have to restart the minion. So anytime we're doing updates or we say, I want you to grab this data too, I have to go bounce a minion as well. So that's another downside of putting it in the grain system. Also, one of the big problems was if we were using, from a security perspective, some of you are probably familiar with using Jinja to do conditional statements in your pillar data or in your targeting or something like that, right? If this machine is in this role, then it should have access to this pillar data or these credentials or whatever. Well, grains could be modified locally, and if I was malicious, I could get on a system, change the grains, and then suddenly maybe have access to new pillar data that I was not supposed to have access to. So we thought, all right, here, lessons learned with the grains, probably not the best idea. Let's move it to pillar. So let's use an external pillar module to query the CMDB. This will address the issue of API credentials on every host. Because the master is doing the external pillar connection, only the master needs to know about the credentials. Only the master is making connections to the CMDB, so we can reuse connections. We're not just bombarding it. Now, the master is still sending a lot of requests, but it's from one source, and we can reuse that connection, and so we found it was a lot more efficient. Pillar data does update in real time. You can just do a salt util refresh pillar, and you've got your new data. You don't have to restart a minion anywhere. And from a security perspective, because the pillar data is all on the master, somebody couldn't get into a minion and change anything to suddenly be granted new access to some pillar data that they wouldn't normally have. So we thought, all right, we need to kind of step back with this, redo it. So we went back to the drawing board, rewrote it to use external pillar. Is anybody familiar with external pillar? Are you using it for anything else? Okay. So it's essentially just the master. Anytime a minion says, hey, I need my pillar data, you can have it trigger another module or a script or something to connect out to a CMDB or to connect. I mean, I've thought about mocking one up just for an example. I don't know that anyone should use it, but technically you could use external pillar to read your CMDB that is a spreadsheet. There's Python modules for reading Excel, right? So you could just external pillar, open this file. Technically you do. It's probably not the best way to do it, but you could do it. I've thought about mocking it up just as an example of an external pillar. So it doesn't have to be a big fancy CMDB like we have or something, but it could be as simple as a spreadsheet. Anyway, it's just the concept of external pillar, if you're not familiar with it, is it triggers some new connection or some script or something to populate data and stuff it into Salt's pillar dictionary. So we deployed the external pillar and feeling pretty good about that. Things were working better. We didn't knock down the CMDB this time. And so we started extending that. Okay, this is the best approach for us. This is working best. So what kind of data do we want out of our CMDB? Our CMDB stores data like alerts information. So we have monitoring infrastructure with Nagios that does checks and then sends alerts and so on. But it sends the alerts in through the CMDB API, And there's a dashboard in there that our NOC can use to see incoming alerts and alert status and that kind of stuff. So, well, if that stuff's in the CMDB, I could query for that too. So in Salt now, I can query, show me any system that has an active alert. Just write in one Salt execution module, and I get a result of these 3 boxes have alerts. Here are the alert names. Here's the status, the disposition. Do they have an assigned ticket or not? All that kind of stuff. We have system attributes or system details, CPU, RAM, MAC address, IP, network, DNS name, vendor, role, environment, all that kind of stuff. And then we also have a section for just custom attributes, key value pairs that we can define as just different values we want to use in our templating. So, and it kind of uses an inheritance model. So if you're in this environment, you get a default set of attributes that you can always expect to be there, and you can templatize and query those and use the answers, and we can maintain that centrally, which is what we want to be able to do with the CMDB, of course. Excuse me. So at this point, I'll show some examples of what we have in our CMDB and how we're using it. But at this point, I can't imagine not having this external pillar and a CMDB connection in Salt. Salt's really very powerful, and the more data you can feed it, the more powerful it becomes. So now we can target based on, instead of just Salt star or whatever, or Salt minion name, we can target based on pillar data of, I want to target only the systems that have alerts, or I don't have a demo for this right now, but I've demoed in the past. Target all the machines that are alerting on Apache, and then do service restart on Apache. So we're filtering not just on a specific named list of something or a glob, but the status of the system, the health of the system. Show me what's alerting and target those and do an action. So I have some screenshots. I don't know how well you can see those, but we populate a new key inside of our pillar tree called CMDB, and then under that has some subkeys, alerts. So an example of the alert data we can get in Salt. Here's the date, the details, disposition. So the postfix queue is in a warning state. Here's an assigned ticket. It's in the TechOps Jira. We're a big company, so we have some different Jira installations, but that's, anyway. So I can easily scan my entire infrastructure. Does anybody have an alert? And sometimes I'll have alerts that the NOC doesn't know about yet. I see them first because they're in the alerts DB, but they haven't been processed. They're in a different disposition. So this is the alerts data we have. We have details. So device service, which is kind of like a role, right? This is a web server or a database server or whatever. The device state. Is it online or offline or on duty standby, or is it, I can't suddenly think of the word for we're going to throw this away now. Decommissioned. IP addresses, environments, manufacturers, model. So I can target, hey, I want to target just my systems that are VMware virtual guests, or only target my HP stuff or my Dell stuff or whatever hardware I have, because that data is going to show up here in the model field inside of the details section. And a couple of things I scrubbed out for security reasons. You guys don't need to know that my IP address is 10.0.1.1 because nobody uses that. The attributes, like I mentioned, what profiles does it use? What Jira project? Where's the provisioning server or the NTP server, Git server, Yum server? We can store all these in here, and then we can use them in our templating, in our states, in our targeting. Different security environment groups. What role groups should be allowed on that machine? What profile does this one use? Stuff like that. All of this is stored in there. And then we also have, oh, I forgot to mention this one. Let me go back for a second. So another thing that we wanted to manage in our CMDB was secrets and credentials. So we generally use, or we use to store secrets, so passwords, usernames, API keys, whatever. We use Salt's GPG renderer. So we encrypt all of our data in GPG and put it in our pillar tree. And the Salt master knows how to decrypt it and decrypts it when we need it. But at rest, most everything in our pillar is just GPG cipher blocks. Now, that works really well. We've been using it for a while to store our secrets. And we don't have much issue with that, except for when we get to a large scale, a much bigger environment. And some of our environments at Adobe are tens of thousands of servers. If you're familiar with Salt's pillar system, you have to use the top file to grant access to certain secrets. These minions can have access to these secrets, and these minions can have access to these. But when I've got 30, 40, 50, 60 different roles, and I have 10,000 systems, and a top file becomes unwieldy and hard to maintain and just not great. So actually something that we designed was a CMDB-based, essentially CMDB-based replacement for the top file. So we pull this data through external pillar. The secrets section in CMDB queries for what secrets a system should have access to. Those are stored encrypted on disk and then decrypted and shared. But we have this information about what the secrets are as well that machine should have access to. And we can maintain it centrally in the CMDB and use our inheritance model to say anybody in this data center should have access to this, and it propagates down, or in this environment should have that, or so on. But we keep, we've got the last password, the current password, last iteration, which environment and device service. It's all the secrets are bound by role and environment, and so we can be fairly granular about it. So I'm not going to tell you what the passwords are, of course, but we also maintain all of our secret store management through our CMDB and pull that same data out using the same external pillar module. Yes?
So the actual secret data is stored in CMDB?
The secret data is stored encrypted in Git pillar, but the CMDB kind of, the way we wrote the module kind of bypasses the top file, uses what CMDB defines, and then decrypts the secret that it has from Git pillar, and then shares that back out.
Since you're using CMDB for your top file, do you put your entries in at host level, or are you still use both?
It depends on what we're, sometimes it's a glob, sometimes it's a compound match of this pillar value and this pillar value, and I mean, pretty much any of the targeting mechanisms in Salt, we use some combination of at some point. Does that answer your question? Yeah. Close enough, maybe? Okay. So we have all of this data now. So at this point, everything's in pillar, and you can, as we talked about, you can target on pillar. So I could technically say I want to target just the machines where the users have access to a specific secret, or any combination of how you could parse this data. It's just a big dictionary. It's just a big data structure in Python. So any way you want to parse it and use this key and that and a compound match connection of those and create some more complex query, you could use. So we're pretty excited about what we built. Most all of our teams are onboarded and using this. Not all of them, but we're working on it. But now we're happy with the data that we're getting out. We're getting all kinds of data out of our CMDB, but we still have that problem of, well, who's keeping it up to date? How if I add more RAM to this machine and I forget to go into CMDB and update it, it's really never getting updated. So how do we address that? So I want to have a demo, and I'll show you how we automatically maintain our inventory and our system details through Salt to keep our CMDB up to date so that it's actually useful. Because if it's not useful, if it's not accurate, then nobody cares. So let me get my console here. Let me ping my minions, make sure they're all responding. So this is just a demo host. I've got 15 containers on it, and I have Salt running in each of those containers. And I've actually added all of these systems to our CMDB. So I can say pillar.get CMDB. This will show me the CMDB data for all of my systems. So this box, 4 CPUs, device state, kernel, manufacturer, all this stuff is all being queried out of our CMDB. These are not technically KVM virtual hosts, but we don't actually have a field in the CMDB for container yet. Containers, I guess, is still new enough. Should probably talk to somebody about that. I think I know the right guy. So all of these are pulling data out, except for, and I left this as an example, I didn't add this system. So it just comes up with these empty dictionaries. But everybody else has the data. Now, if I want just a specific piece of this, I can say pillar.get CMDB alerts. And it shows me just the alerts. None of these systems have any active alerts. They're not being monitored. But if they were, we're going to have some alerts in here. Pillar.get CMDB details. I just want the details, right? Not the attributes or the alerts or the secret stuff, or I just want specifics. And you can drill down all the way to, right, I want the CMDB, and then in the CMDB dictionary, I want the details, and then under the details, I just want the model. And we can drill down as deep as we want to make this data structure go. We can keep going. Now, to keep it up to date, we took the, we have a CMDB that we kind of carried it over from the grains days when we were using the grains still. A CMDB execution module that will allow us to insert new records that don't exist, update records that do exist but need to be updated, or query and pull data out. And then we added an audit function. So I want to run an audit and compare what the minion knows about itself versus what CMDB knows about it, and potentially sync the two or push the data from the minion to CMDB. Now, if I go back to a comment I made earlier, there are certain things that the minion should be kind of the source of record for, and there's certain things that CMDB is a source of record for. So there are only certain values that we ever push in. I really don't ever push like, you are in a new role, or you're now in rack 42 or something. The minion doesn't really have a concept of that. So there are certain other things that we send, but not everything. So I can audit my systems here, and this will show, now, because it's an auditing function, it only shows me where things are different. So the CMDB thinks that this machine's IP is this, but the minion says, well, it's this. There's a difference. I don't know why, but there's a difference. So this shows me where where they are different. If I went into CMDB and changed some other values, I would get more output. In this case, these are just the only things that don't sync up right now. So I can do CMDB audit update true. Oh. Is Colton in here? Some of my coworkers wrote this part, and I just misused the function. Anyway, there's a, I don't remember the key right now, sorry. That's right. sys.doc CMDB. Does everybody use sys.doc? Yeah, no, yeah. There's an execution module called sys with a doc function, and you can give it a salt module, and it'll show you all the documentation about every function in that module. It's all automatically generated. If it doesn't work, I'm blaming you.
If there's no documentation, you can use sys.argspec and the module and function name, and it'll list the arguments that will be accepted.
Okay. I don't think I have used that one before. Maybe Colton didn't write documentation for this one. I'm going to cancel that. Anyway, there is a function in there that I'm blanking on right now that if we toggle it on, it will take the grains data and push it to CMDB so it stays up to date. So between the combination of the external pillar module that we have and this CMDB execution module, this is now our standard method of tracking all of our inventory and making sure our CMDB is accurate and up to date. We have a corresponding CMDB state module. So if we want to we can apply a state that will sync CMDB or track a file, and if this file changes, sync it or alert us or something like that. So part of some of you guys were in my security talk earlier, part of the compliance is inventory management and knowing what you have and where it is and what its details are. So a related but kind of separate piece to Hubble that I talked about is inventory management, which is done through this and our audit module. Let's see, so if I can get this back. All right, so we built some cool stuff in here. This keeps our CMDB up to date. At this point, I could target an entire data center and say, show me where you don't sync up with CMDB, and sync yourself, update it. So now, given the idea that the CMDB is only as useful as it is accurate, well, we could run this CMDB audit function with the update value on, maybe via the Salt scheduler or a cron job every day, and it just makes sure CMDB is up to date every day. So we know that it's, at least within the last 24 hours, it's accurate. If it's not that accurate, then why use it, right? So, excuse me, I wish that I did have this open source that I could share with everybody, but again, it's very specific to our CMDB. But the concepts can be shared, the general same ideas can be shared. Actually, can I ask what CMDBs are people using? Is there, anyone care to share what? Device, that sounds familiar. Device 42, yeah? ServiceNow.
This is probably cheating, but the AWS console.
Is that cheating? Maybe not, yeah?
What about driving builds with CMDB? Like, what about using it as your source of truth to tell Salt what to do?
We're talking about that and trying to decide the best route to do it, but
Yeah, like the scenario I'm talking about is that you take in a self-service ticket from a user, say I need a new VM XYZ, right? And rather than have that go down to somebody's console and they get to type in some YAML, which is always the most error-proof process that you could possibly have, or organic middleware, you would just approve that and put it in the CMDB with a field of, pending, and have Salt pick that up from, request, push it through, generate what it's got to generate, and use the CMDB as a source of truth.
it's totally possible, yeah. We don't have anything built along those lines yet that I could show you, but like I said, we're talking about how how we might start integrating that. One thing that we're actually doing, just a sec. So everybody's familiar with when you spin up a new minion, there's a key that gets generated. The master has to know about the key, and the key gets stored on the master, and right? Well, one thing that we want to do to better facilitate, and we will share this, by the way, to better facilitate having multi-masters or cluster masters, we are working on making the key store pluggable. So the key store doesn't have to be on disk. It could be in MySQL or Postgres or Redis or wherever you want to put it, and all of the masters subscribe to that central database. Or in this case, when I create a new machine profile in CMDB, I can click Generate Salt Key, and the CMDB is the key store for the salt communication. So we are actively talking about that. We did some work on it last night at the sprint. Anybody go to the sprint? Yeah, good? Yeah, okay. But we will share that when it's done, by the way. The clustered master pluggable key store thing. In the back, yeah.
It sounds like you have a multiple master syndic thing set up, so it might not necessarily work in your environment, but is there any reason, or did you guys come across any obstacle to just using the salt master event bus to update the CMDB?
I didn't, we do have a lot of, well, we have a central master, we have a lot of syndics, so we have multiple layers, and I believe there was a number of big improvements with the syndic system in 2016.3, but previous to that, we were building this in 2015.5 and before, and getting that data to go up through those different layers of syndics sometimes is problematic, so we didn't go that route, but maybe with these improvements we could do that better. I haven't really looked at how the new syndic kind of handles that better, but yeah. Anybody else have a question while we're? Yeah.
So you showed the CMD module for syncing stuff from grains to your CMD. How do you handle the other data? Or is that just like
The other stuff, yeah, right now it's kind of manual, and a lot of it, I mean, stuff like the rack and the data center and the colo and stuff doesn't really change that much. So when DC Ops gets the chassis and stuff, they'll rack them up and they populate that, and then we usually don't have to change that often. But we can change things like role and different attributes and stuff. But yeah, the initial entering is we'll order 50 chassis or whatever. It goes to DC Ops. They rack them, power them, connect them, and then import a PDF or a spreadsheet with here's all the new data. So that's kind of manual, kind of automated. Import a list, but yeah, that part is kind of still manual-ish. Okay, that actually is kind of near the end. So more questions is fine. Yeah.
You mentioned you're using external pillars to get the data from the CMDB. Maybe I missed it, maybe you said it, I don't know. What about the performance? Because you need to render it on the master, right?
Mm-hmm.
So you would run the external pillar every time any minion updates its pillar data. Do you
Right.
the request for the CMDB at that time, or do you cache it and say we have some time until we need to update it?
Usually it's just refreshed when it's requested to be refreshed. So if you run a refresh pillar, or a high state, I believe, runs a refresh pillar underneath, a couple other events might refresh it, and we just do it real time. And luckily our CMDB is designed really intelligently, and we can scale it out. So we have read-only CMDB endpoints in each data center that we can hit. So I could have 10,000 all hit that one, but they don't affect Dallas or San Jose or Texas or whatever, And just by scaling the CMDB, we've found that we've been fine. The master handles everything, and historically, a lot of our masters have just been virtual machines, not really powerful, and it's been fine. I mean, it's just a Python data structure, really. It's not really too intensive on it, no. Anybody else? No? Okay. If you have anything else you'd like to talk about, I'll be up here for a few minutes.